Welcome to part 2 of the disease causation video lecture series. Now for this video, I'll be focusing on the sufficient component cause model. Picking up from where we left off previously, recall from the Introduction to Epidemiology video series that Sir Richard Dahl and Sir Richard Pato from Oxford University in the late 1940s carried out a longitudinal study among male British doctors investigating the association between smoking and the occurrence of lung cancer over time. Now, with such findings, physicians, researchers, and epidemiologists were made to rethink disease causation in that there might be a component of interaction between putative causes of disease. Like, for instance, some diseases are caused by genetic factors, and other causes, such as factors in the environment, interact with genetic factors, thus making some individuals more vulnerable than others. Thus, we introduce the terms sufficient cause, which pertains to a cause that inevitably or is unavoidably bound to produce or initiate an outcome. And by inevitability, we mean that there is a definite or direct causal pathway between sufficient cause and the disease, and necessary cause wherein an outcome cannot develop in its absence. And thus, the sufficient component cause model was developed, in part because clearly the agent-host-environment model, which was discussed in the previous video, did not really work well for many non-communicable diseases such as cancer. Now, such a model was initially conceptualized and proposed by Harvard University epidemiologist Kenneth Rothman. Now, in this model, an individual factor that contributes to cause disease is presented as a piece of a pie. And after all the pieces of said pie fall into place, the pie is complete, then the disease occurs. Now, Rothman coined these individual pie pieces as component causes, which can be viewed as individual factors associated with a disease. And we already talked about the concepts of risk factors previously under the Introduction to Epidemiology video series. Now, to elucidate component causes even further, they are any one of the set of conditions which are necessary for the completion of a sufficient cause, inevitably leading to the disease. And this I've already touched on earlier, stressing on the interaction between intrinsic host factors such as genetics, the agent if the disease is infectious, and the environment, thus reconciling it with the epidemiologic triad concept. Now let us incorporate the terms sufficient cause and necessary cause that I introduced earlier. The sufficient cause, which inevitably leads to disease, is seen here as a complete pie. So there's a definite or direct causal pathway between sufficient cause and the disease. And since we are talking about the complete pie, losing any one of these pieces would mean that the disease would not occur. This stresses that a sufficient cause is not a single factor, but a minimum set of factors and circumstances that, if present in a given individual, will produce the disease. It is also important to understand, however, that disease may have more than one sufficient cause, with each sufficient cause being composed of several component causes that may or may not overlap. Now, this means that different individuals will have different sets of individual components that combine to produce a sufficient cause. Now, how about the necessary cause? Let's assume that a disease has more than one sufficient cause, and each of the sufficient cause is made up of a set of factors or circumstances that all have to be present for the disease to occur. The necessary cause, then, is that component that appears in every sufficient cause. And naturally, without it, disease would not occur. Likewise, by itself, the necessary cause is not enough to cause disease. It has to interact with the other components of the sufficient cause pie. Now, as was mentioned earlier, each sufficient cause is graphically represented as a complete pie, and all pieces of that pie have to be present in order for disease to occur. And for a particular hypothetical disease, let's say we have 3 sufficient causes for it. So each sufficient cause pie must have all component pieces present for this disease to occur. And notice as well that piece A is present in all 3 sufficient cause pies. That piece would be the necessary cause, which by itself will not result in disease. Now, here are features of the sufficient component cause model, some of which you've probably already noticed in the discussion earlier. The completion of a sufficient cause is synonymous to the occurrence of the disease. The component causes can also act far apart in time. This is particularly true among diseases such as cancers, where an accumulation of a number of acquired mutations necessary for disease occurrence happen over an extended period of time. Now, each component cause may have a different induction period, and by that we refer to the amount of time that elapses between the initial exposure and the start of the disease. Now, this should not be confused with the latent period, which is the interval between the disease onset and the clinical detection of the disease, either by screening or as a result of symptoms that cause individual to consult a physician and be given a diagnostic workup. Next, a component cause does not only mean the presence of a causative exposure. It can also involve the lack of a preventive factor. And I think that is quite self-explanatory. Next, blocking the action of any component cause prevents the completion of the sufficient cause, and therefore prevents the disease by that pathway. In general, it is not necessary to identify all sufficient cause components to be able to effectively prevent the disease, since the removal of one component may interfere with the action of the others and thus prevent the disease. Now, going back to the Dahl and Pito study, while cigarette smoking is one component of the sufficient cause of lung cancer, it is not sufficient in itself to cause it, since you can have long-time smokers who are surprisingly cancer-free. It is likely that other, usually unknown factors are involved. Genetics may play a role as well. However, bottom line is, cessation of smoking alone can already reduce the number of lung cancer cases in the population by as much as 90%. Finally, a single component cause is rarely a sufficient cause by itself. Now, even exposure to a highly infectious agent such as measles virus does not invariably result in measles disease. It is also dependent largely on host susceptibility and a myriad of other host factors. Now, this probably can be extended to the novel coronavirus, since we have asymptomatic cases. However, we have to be careful in making that claim, since even though we are already at least 6 months into the pandemic, there are still aspects of the disease that we don't know. And the asymptomatic cases may actually be pre-symptomatic cases, wherein these individuals show signs and symptoms of the disease a few days later. Now, perhaps to facilitate better understanding of the difference between sufficient cause and necessary cause, let's go back to some college-level philosophy and talk about sufficient and necessary conditions. Let us not forget, however, that in the epidemiological sense, a sufficient cause is made up of different component causes that have to be present for an outcome to be effected. So there can be 4 combinations here, and they are as follows. Now here's an example of a necessary but not a sufficient cause. Sam's being a male is necessary, but is not sufficient for his being a father. Clearly, for him to be a father, he must also engage in unprotected sex with an adult biological female and have a child together with that female. Now here's an example of a sufficient but not a necessary condition. Sam's being a father is sufficient but is not necessary for his being a male. While fathering a child is enough of a condition for someone to be considered a biological male, there are other conditions besides fatherhood that define what a biological male is, like having the XY chromosome genetically and having the corresponding anatomical parts and characteristics. Now here's an example of a necessary and sufficient condition. Sam's being a father is both necessary and sufficient for his being a male parent, because only biological males can father children, and a father is technically a parent. Now for the last condition, neither necessary nor sufficient, we have this example. Having a married brother is neither a necessary nor a sufficient condition for being an aunt. Now this is a statement that is from the female's point of view. Now if your brother is married, you become the spouse's sister-in-law, not aunt. Now, let's apply this epidemiologically. Recall that Koch's postulates imply that a microorganism isolated in a diseased individual is both a necessary and sufficient cause for that disease. But we know that these postulates are already quite antiquated, and for many diseases, both communicable and non-communicable, Koch's postulates for determining causation are grossly inadequate. We also know for a fact that a necessary cause that is also sufficient is a rare occurrence. Now, one such example would be with Tay-Sachs disease, something you have encountered already in biochemistry. A gene mutation associated with Tay-Sachs is both necessary and sufficient for the development of the disease. Everyone with the mutation will develop Tay-Sachs disease eventually. No one with the mutation will ever have it. Now, the following are examples of necessary but not sufficient causes for disease. Now, having an adenoma is indeed a necessary risk factor for colon cancer and has to be monitored and sometimes removed for preventive purposes. But you can also have individuals with intestinal adenomas that do not become malignant, probably because they don't have the genetic predisposition for it, or have managed to minimize cumulative mutations that lead to development of colon cancer. Now, for cervical cancer, while infection with high-risk human papillomavirus is necessary, it has to have interactions with factors such as immune deficiency, genetic factors, and certain environmental exposures for it to sufficiently cause cervical cancer. Same with pneumocystis jirovecii infection. While a necessary cause for pneumocystis pneumonia, immunocompetent individuals are much less likely to develop the disease, if ever. It can, however, cause potentially lethal pneumonia in persons whose immune systems have already been weakened by HIV. Now, this one is an example of a sufficient but not a necessary cause. For one individual, history of childhood sunburns interacting with genetic predisposition are sufficient for the occurrence of melanoma. But understand that different individuals will have different sets of individual components that combine to produce a sufficient cause. Perhaps for another individual, the component causes of his or her a sufficient cause would be, let's say, presence of certain types of moles, plus having fair skin, plus frequently visiting tanning salons. And lastly, we have causes that are neither sufficient nor necessary. As an example, gonorrhea is neither necessary nor sufficient to cause pelvic inflammatory disease or PID. A person can have gonorrhea without ever developing PID. They can also have PID without ever having been infected with gonorrhea because there are other bacteria that cause PID. Now here's an example that pertains to AIDS. Now from the pie figure here, a sufficient cause for AIDS for an individual might consist of the following components: exposure to an individual with HIV, repeatedly engaging in risky sexual behavior with that individual, and the absence of antiretroviral drugs that reduce viral load of HIV. Now, this suggests that the presence of these three component causes is sufficient to produce AIDS in this individual. Note further, if any one of these components were absent, AIDS would not occur. Now, take note that this particular sufficient cause is only one manner in which AIDS could occur. Now, as I mentioned earlier, different individuals will have different sets of individual components that combine to produce a sufficient cause. Now here's another example, also taken from the same source, this time on TB. We note here two sufficient causes, with each sufficient cause composed of different component causes, all of which should be present for a sufficient cause to be able to result in disease. Of course, in reality, there may be other sets of sufficient causes for TB. You can note in this figure as well that the sufficient causes of TB may differ in their components, although some components might be shared among different sufficient causes. In this case, we see exposure to TB as a common cause, and we can say that this particular component cause is a necessary cause as well. Now, here is yet another example. Recall that a sufficient cause has different component causes that complete the pie. Here we have three pies or three sufficient causes to, say, lung cancer. Let us suppose component B is smoking and component C is asbestos. Earlier, I talked about interaction wherein the effect of two or more causes acting together is often greater than would be expected on the basis of summing the individual effects. Now that is why there is a particularly high risk of lung cancer in people who both smoke and are exposed to asbestos dust. Now with interaction, risk is multiplicative instead of additive. If lung cancer risk among smokers is, let's say, 10 times those of non-smokers, and the risk of lung cancer with exposure to asbestos dust is 5 times that of unexposed individuals, the risk of lung cancer now goes up to 50 times if an individual has both. And while frequently we don't know what the other component causes in the sufficient cause pie are, removal of smoking and asbestos exposures are already enough to prevent disease occurrence. Now recall from earlier as well that lung cancer can develop in persons who have never been exposed to either smoking or asbestos dust. If that is the case, then a proper model for lung cancer would have to show at least one more sufficient cause pi that does not include either component B or component C. Now, if you read the reference I provided in red canvas, you will see that there are 4 types of factors that play a part in disease causation. Now, all of them may be necessary causes, but they are rarely sufficient on their own to cause a particular disease. Now, first we have predisposing factors, which, as you can see, are characteristics inherent to the individuals themselves. Now, next we have enabling or disabling factors. As you can see here, these are mostly factors that have something to do with an individual's socioeconomic state. Next are precipitating factors. Exposure to a specific disease agent may be associated with the onset of a disease. And then we have reinforcing factors. These include repeated exposures to an offending agent or substance, environmental conditions, and perhaps high levels of stress or unduly hard work, all of which may aggravate an already existing or already established disease or injury. Now, I will end this video lecture here. Now, please proceed to the next and last video for this series, where I will be talking about the causal guidelines as suggested by Sir Austin Hill.